Right now, somewhere inside your wall, heat is moving, not through the glass, not through a crack you could find with a flashlight, through the frame itself, through the 1-inch zone where your window frame meets your framing lumber, sealed with a single bead of caulk that has never, in the entire history of American residential construction, been required to do anything more than keep rain out of the rough opening. Studies of standard double-pane window assemblies show that up to 30% of a home's winter heat loss occurs at the frame-to-wall junction, not at the glazing that manufacturers spend billions marketing to you every January when your heating bill arrives. That junction is not a flaw in your particular house. It is the design. It is the intended outcome of a construction method standardized not because it performed well thermally, but because it was fast, cheap, and legally defensible under a code system that was never asked to care about what happens at the edge of a window frame when the outside air drops below freezing. No sound announces it. No visible gap betrays it. Just heat bleeding silently outward through a thermal highway running from your furnace to the frozen exterior every hour of every winter on a route nobody in your building code ever asked a contractor to close. 2,000 years ago, Roman builders and Norse craftsmen solved this exact problem using recessed masonry reveals and layered interior shutters that kept the frame from ever making direct thermal contact with the cold side of the wall. They had no thermometer, no thermal imaging camera, no U-factor rating label. They had physics, and they trusted what the climate taught them, and for more than a millennium, the buildings they constructed held heat with a geometry so simple it requires almost no explanation. Then the American window manufacturing lobby and the fast-track residential construction industry made sure the installation method, not the glass specification, stayed invisible to every building code you have ever lived under. By the end of this video, you will understand exactly why the frame-to-wall junction was written out of American building education, and you will have the precise installation sequence that European certified builders use today. I'm your host, and welcome to this channel. Subscribe and hit the bell, because what the window industry hopes you never compare is already public record in Germany and has been for 30 years. To understand how this installation gap became invisible, you have to go back to the moment humans first cut a hole in a wall and tried to keep the cold outside where it belonged. The archaeological record of Roman villa construction and Norse longhouse excavations, sites documented by researchers across northern and central Europe, describes the same instinctive thermal geometry repeated across civilizations that never communicated with each other, across centuries with no shared technical literature, across climates that each independently taught their builders the same hard lesson about where heat goes when you give it a path to follow. The window opening was not flush with the exterior face of the wall. It was recessed, set back, pulled inward so that the frame was surrounded on 3 sides by the thermal mass of the wall itself, never directly exposed to outside air on its edges, never made into a conducting bridge between interior warmth and exterior cold. The reveal, the deep stone or heavy timber throat of the opening, acted as a buffer zone, a dead air pocket, a geometry-based insulation layer requiring no additional material cost beyond the labor of cutting the opening deeper rather than stopping at the first available surface. They never let the frame touch the cold side, and they had no thermometer to tell them why it worked. Here's the number that changes everything. Wood conducts heat at approximately 0.12 watts per meter Kelvin. Still air conducts heat at approximately 0.025 watts per meter Kelvin. That means the wooden frame of your window conducts heat roughly 5 times faster than the air gap it replaced when the builder pushed it flush to the exterior sheathing and drove the nail fin home. This is not a new discovery. In 1822, the French mathematician and physicist Joseph Fourier published his formal law of heat conduction, a mathematical framework so complete and so permanently correct that no meaningful revision has been required in 200 years. Heat moves through a material at a rate proportional to the temperature difference across it and the conductivity of the material carrying it. A metal-fastened wooden frame set flush against cold exterior sheathing, with no insulation between the fin and the framing, is a direct conductive bridge operating at maximum efficiency every time the outdoor temperature drops. The physics was published in 1822. The American window label still does not account for it. The ASHRAE Handbook of Fundamentals includes detailed chapters on thermal bridging that describe exactly this mechanism in precise, unambiguous language. But the U-factor rating on every window sold in the United States, governed by the National Fenestration Rating Council, measures the center of the glass, not the frame, not the junction, not the installed assembly, as it will actually exist inside a real wall in a real winter. Medieval Northern European builders, working without ashray and without Fourier and without a single piece of measuring equipment recognizable to a modern engineer, operated on a principle their climate made unavoidable. In Germany, Scandinavia, and the Alpine regions, places where winter is a physical negotiation that shapes how every structure is conceived, builders positioned windows at the interior face of the wall, set back from the exterior by depths ranging from roughly 4 inches to more than a foot. The window reveal was not decorative, it was thermal engineering expressed in geometry, requiring no manufactured product, no special material, no code approval. The frame was wrapped on its exterior edges by continuous wall material, interrupting the conductive path from warm interior to cold exterior at every point except the glass itself. Physical surveys of surviving medieval structures in Northern Europe describe this configuration as standard and unremarkable, the obvious way to install a window in a climate that punishes carelessness with cold. Dr. Wolfgang Feist, who founded the Passive House Institute in Darmstadt, Germany in 1988, did not invent this principle. He formalized it, measured it, and built a certification system around the results. But the geometry he codified was already ancient. The correct position for a window frame was understood before the printing press existed, and then forgotten systematically and completely in American tract housing. This is where the story changes. After the Second World War, the United States began building residential housing at a scale and speed with no precedent in human history. The Federal Housing Administration published minimum property standards in the late 1940s and 1950s that established the legal floor for residential construction quality. Not the ceiling, the floor. Levittown and its descendants were built to those minimums and nothing above them, because the economics of speed made anything above the minimum a competitive disadvantage. The nail-fin window, which allows a single worker to set and secure a window unit from the exterior in under 10 minutes by driving flanges directly through sheathing into framing lumber, became the national standard not because anyone evaluated its thermal performance against alternatives, but because it was fastest and the code asked no further questions. The nail-fin creates a direct conductive bridge at every edge of the frame, pressing wood and metal against exterior sheathing with no insulation between them. No thermal break, no recessed reveal, no geometry inherited from 2,000 years of cold climate building knowledge. The capillary path between the fin and the sheathing also channels moisture inward during rain events, a secondary failure mode that caulk was never engineered to permanently prevent. The flush exterior mount became the national default between 1945 and 1970, was codified into trade practice, and was never re-examined by the systems that had adopted it. Speed was the point, warmth was never the spec. The Building Science Corporation, whose technical publications have shaped American building enclosure science for decades, documented what the flush installation actually looks like from inside the wall using infrared thermal imaging. Researchers found that the rough opening framing surrounding a nail-fin window installation shows a consistent cold zone extending several inches into the wall cavity on all 4 sides of every window examined. This cold zone is not the glass underperforming. The glass performs exactly as its label claims, within the conditions of the laboratory test that produced the label. The cold zone is the junction, the convergence of 3 simultaneous failure modes at a single location that every American contractor is trained to seal with caulk and consider finished. Heat loss through direct conduction at the frame and fin assembly. Air leakage through the discontinuous air barrier at the rough opening where the house wrap was cut, folded back, and never reconnected to the window frame with a continuous seal. Moisture condensation at the dew point, which under standard American wall assembly conditions falls precisely at the jamb inside the insulation layer, invisible until it announces itself as rot, mold, or a window that no longer operates because the rough opening framing has shifted beneath it. The glass is fine. The crime scene is the inch around it. Here is what makes this structural rather than accidental. In 1992, the United States launched the Energy Star program for windows, a joint initiative of the Environmental Protection Agency and the Department of Energy. The program adopted the NFRC rating methodology, measuring center of glass U factor under laboratory conditions. Researchers and technical critics, including work associated with Lawrence Berkeley National Laboratory, have documented that the installed assembly performance of a standard American window, when frame conduction and air leakage at the junction are included, can be 40 to 70% worse than the rated U factor printed on the label. 40 to 70% worse. American homeowners buy triple pane windows rated for exceptional thermal performance and install them using the same flush flush nail fin method that has been creating unrated thermal bridges since 1947 in rough openings where the air barrier was never connected and the jam insulation was never fitted. The label tells you the car's top speed. It does not tell you the wheels are installed backwards. The American Architectural Manufacturers Association, whose installation standards govern what contractors are trained to do on job sites across the country, produced installation guides through the 1990s and 2000s that addressed flashing sequences and water management in careful detail. Thermal bridging at the jam is not addressed. Air sealing at the rough opening is listed as recommended, not required. The International Residential Code specifies window installation requirements that align with the AAMA framework and ask nothing further. Code compliance gives a contractor legal protection. Thermal performance remains voluntary, unverified, and unmeasured at the point of inspection. Legal is not warm, compliant is not efficient, and nobody who profits from replacement window sales every 15 years is motivated to demand that the installation method change. But here is the real reason this disappeared, and it is not a conspiracy. It is a structural outcome produced by the ordinary logic of incentives operating over decades. The American trade education pipeline for window installation, certification programs, apprenticeship curricula, continuing education modules through builder associations focuses entirely on water management, where to lap the flashing, how to overlap the house wrap, how to sequence the caulk at the head. These are real skills addressing a real failure mode, and they are taught thoroughly. In Germany, the Handwerkskammer, the National Chamber of Crafts certifying master-level window installers, includes thermal bridge analysis, blower door testing at the window junction, and air barrier continuity verification as core competencies every certified installer must demonstrate. An American window installer can be fully certified, fully insured, and fully code compliant without ever encountering the phrase thermal bridge in a training context. The knowledge was not banned. It was simply never included, and this is where the story enters its modern turn. In the early 2000s, building scientists in the United States began publishing technical guides that named the frame-to-wall junction explicitly as the primary failure point in residential window installations. Joe Lusteburek of the Building Science Corporation and researchers affiliated with the Department of Energy's Building America program introduced language into American building science discourse that described the ancient geometry in modern terms. The any window, which set at or inward of the insulation plane, with its frame surrounded by insulation on three sides and its air barrier connected continuously to the wall membrane using vapor open tape systems, is thermally identical in principle to the recessed reveal of every medieval German and Scandinavian building ever excavated. The rediscovery has a name. Almost no American contractor has heard it. When builders began implementing this method in real construction projects, they discovered a permitting system designed by habit to reward the old default without question. Continuous exterior insulation, the layer that makes any installation thermally correct, creates a non-standard rough opening depth that most local building inspectors have no established protocol for evaluating. Cases documented through Passive House US and accounts from high-performance builders describe permit processes that move without friction for a nail-fin flush installation and generate requests for additional engineering documentation when an inward-set thermally broken installation is proposed. The wrong method gets a permit in one day. The right method needs an engineer's letter and 2 extra weeks. And then you reach the data that cannot be argued with or dismissed. In Germany, Austria, and Switzerland, the Passive House Institute has been certifying buildings to a verified monitored performance standard since 1991. The first certified passive house in Darmstadt, monitored continuously by Dr. Feist's research team, demonstrated heating energy consumption more than 80% below that of a standard German new build of the same period and size. That monitoring has continued for more than 3 decades. The database of certified buildings maintained by the Passive House Institute includes schools, hospitals, apartment towers, and single-family homes across Central and Northern Europe, everyone using window installations that position the frame at the insulation plane, connect the air barrier continuously using tape systems engineered for long-term vapor management, and specify warm edge spacers with triple pane glazing in frames designed to minimize edge conduction. Studies across multiple European certified installations, monitored over periods exceeding 15 years, document heating energy reductions of 60 to 90% compared to standard regional construction of equivalent size. The EU Energy Performance of Buildings Directive has progressively pushed these verified methods into European mainstream building code over 2 decades. The experiment already ran for 30 years. They published every result. America just never opened the journal. What you can do today requires no engineering degree and no imported product product unavailable here. It requires understanding 6 steps that together eliminate the failure mode bleeding heat from American homes since the first nail gun drove the first nail fin into post-war sheathing. First, the rough opening air barrier, a liquid-applied membrane or purpose-made tape connecting the window frame continuously to the wall's weather-resistive barrier on all 4 sides, with no gap and no corner left to air movement. Second, the sill pan flashing, sloped outward toward the exterior, physically draining any water that enters the junction rather than relying on caulk to hold indefinitely. Third, frame position, set at or inward of the insulation plane, not flush to the exterior sheathing where the frame bridges directly between conditioned interior and frozen exterior air. Fourth, jam insulation wrap, rigid foam or mineral wool fitted precisely into the gap between the nail fin and the rough opening framing, eliminating the air pocket that carries heat outward by convection around the frame perimeter. Fifth, interior air seal, acoustical sealant or a purpose-made compression gasket at the drywall return, permanently closing the last infiltration path from interior conditioned air into the junction cavity. Sixth, blower door verification, a whole house pressure test conducted after the windows are installed and before the drywall closes the rough opening, because the only way to confirm the junction is sealed is to pressurize the house and find the leaks while you can still reach them. 6 steps, no exotic materials, no tools beyond what a careful builder already owns. A physics problem solved in stone and timber before your great-grandparents were born, recovered by building scientists in the early 2000s, proven in monitored European buildings across 3 decades of published data, and still absent from the standard American installation guide that ships in the box with every window sold at every building supply retailer in the country. Measured comparisons between standard American window installation and thermally correct assembly, documented through energy audits, blower door studies, and whole building monitored performance reports, show heating load reductions that compound across the full house energy budget in ways that make the additional labor cost of correct installation recoverable within a small number of heating seasons, even in climate zones where winter is mild by European standards. The rate of heat conduction through a material is governed by Fourier's law, written in 1822, confirmed by every thermal camera ever pointed at an American window frame, unchanged by any building code cycle, indifferent to the economics of the replacement window industry. The frame junction has not changed since the nail gun made it easy to ignore. The cold outside has not changed since the glaciers defined the climate that medieval European builders learned to respect. Only the awareness of the gap between warm interior and frozen exterior has been managed, carefully, structurally, profitably managed by a code system that defines legal minimums and labels them performance, by a trade education pipeline that taught water management and left heat transfer for someone else to address, by an industry whose revenue model depends on the replacement cycle that correct installation would interrupt. The frost forms on the outside of a properly installed window, not on the inside of the glass, not spreading across the jamb on a January morning, not staining the drywall 6 inches from the frame where the cold zone meets the interior finish. When the installation is correct, when the frame sits where the medieval builders placed it, where the physics always demanded it, where the geometry interrupts the bridge before the heat can cross, the boundary holds, silently, without electricity, without a monthly bill, without a warranty claim or a contractor who tells you the window needs replacing when the installation is what failed. It held for 2,000 years before the nail gun arrived and made carelessness fast. It still holds in every certified building in Darmstadt and Vienna and Zurich where the monitoring data is filed, published, and waiting for anyone willing to open the document. The wall already knows the answer. We are just catching up.